Hello, dear engineers and technocrats. In today's session, we will learn to plot OC curve for single sampling plan. We will also compare an actual OC curve with theoretical OC curve. You know, in single sampling plan, a lot is submitted by the supplier. From this lot, a customer takes a sample and check or inspect all the items of the sample. And if the number of defectives found in the sample are less than and equal to acceptance number C, the entire lot is accepted by the customer. And if defectives found in the sample are more than acceptance number C, then this entire lot is rejected by the customer. So this is the simple procedure of single sampling plan. Now what should be the ideal values of these samples? What should be the sample size and what should be the acceptance number? These are the two important parameters of a single sampling plan, and we have to determine the optimal values, because you will see later during this session that the producer wants to keep sample size as low as possible and acceptance number as high as possible, whereas the customer wants to keep sample size as large as possible and acceptance number as low as possible. So, as far as values of N and C are concerned, both supplier and customer have some contradictory preferences, and so one need to strike a trade-off considering the views of both the supplier and the customer. And we know that probability of accepting the lot in single sampling plan is then when we have number of defectives less than and equal to acceptance number, the entire lot is accepted, otherwise it is rejected. The operating characteristics curve is a curve between probability of accepting a lot and fraction defective. Now this curve is used to measure the effectiveness of a sampling plan. When we say effectiveness of a sampling plan, it means this OC curve should have a very good discriminating power. The curve should be able to accept a very good quality lot. When fraction defectives are less, there should be a very high probability of accepting the entire lot. And when the lot quality is poor, or we say when proportion defectives in the lot are high, then the probability of accepting such a bad quality lot should be low. Both the parameter acceptance number as well as sample size have significant effect on the shape of the OC curve. You see that as the acceptance number increases, the curve becomes flatter. Similarly, when you see here, as the sample size is increasing, the curve becomes steeper. Or we can say when sample size increases and acceptance number decreases, curve becomes steeper. And you can note down one thing, that discriminating power of OC curve becomes more as the OC curve becomes steeper. So steeper is the OC curve. It has very good discriminating power. It can have very high probability of acceptance for a good lot and a very low probability of acceptance for a bad quality lot. Average outgoing, average quality level is the quality level at which it is the fraction number of defectives at which customer is readily accept the lot, and lot tolerant percent defectives is the highest number of defectives till which consumer will accept the lot, and if the lot quality is poorer than LTPD value, or we can say fraction defectives are more than LTPD values, then consumer will not accept the lot. So the probability of rejection, so probability of rejection at AQL. At AQL is the quality level at which customer is willing to accept the lot, right? And at AQL, probability of acceptance should be high. Now the 1 minus probability of acceptance is known as probability of rejecting a good lot, and that is called producer's risk. Sometimes it may happen that a very good lot is submitted by the producer. When consumer takes a sample out of this lot and inspect it, then he may find most of the defectives in that sample. As a result, a very good lot may be rejected by the by the customer, although it was very good quality lot. And this probability of rejection is known as producer's risk. Sometimes it may happen that a lot of poor quality is supplied, and out of this, when consumer takes a sample and inspect it, then he may not get the number of defectives more than acceptance number. And in such a situation, consumer may accept the lot although it was of bad quality, and that is known as consumer's risk and denoted by beta. So producer's risk is when a good quality lot is rejected by the consumer, and consumer's risk is when consumer accepts a bad quality lot. Now OC curve should be such that this producer's risk alpha should be less than 5% and consumer risk should not be more than 10%, right? So we determine the probability of acceptance at AQL level. AQL and LTPD values are decided based on criticality of the quality characteristics and components used. Like for a washer, you can have AQL and LTPD value different than for another component. So depending upon the usability of the component, these values may vary. The defectives are always counted in numbers, and as a result, they are considered as discrete random variables. For discrete random variable, we have mainly three type of distributions: hypergeometric, binomial, and Poisson distribution. Hypergeometric distribution is used to exactly calculate the probability of having D defective when when lot size is small. Binomial distribution is used particularly when lot size is more than 10 times of sample size, and this function is used to determine the probability of having exactly D defectives. The Poisson distribution is used particularly when lot size is significantly higher than sample size. Sample size is again more than 60 and fraction defectives are less than 10%. And we can use this probability distribution function to determine the probability of having exactly D defectives. Hypergeometric distribution, although gives correct values of probability, but calculations are quite cumbersome. So we may use, it is recommended that one should use binomial distribution, particularly when lot size is more than 10 times of sample size. Here we consider a single sampling plan where lot size is 500 and sample size is 30. So here lot size is more than 10 times of the sample size. So we will use binomial distribution to calculate the probabilities of acceptance when acceptance number is 1, 2 or 3. Now in Microsoft Excel, we may use this function to determine the probability of having exactly C is equal to 1 or 2 or 3 defectives. Whereas this function binom dist, the only difference is here if we put false, it gives the probability of having exactly D defectives. Whereas when we use true here, it gives the probability of having at most D defectives. So it will be the sum of 0, 1, 2, 3 up to D defectives. So let me show you how we can perform calculations on Excel sheet. So here I am explaining how to draw an OC curve when sample size is 30. We will have different acceptance number 1, 2 and 3. Here I have written the values of AQL 4% and lot tolerant percent defective 22%. You can choose different values. Now fraction defective I write here 0, 0.02, 0.04, 0.06, 0.08 and so on. When you drag all these, selecting and then dragging, you can get few values, right? So these are the fraction defectives. Now, in order to get the probability corresponding to sample size n and acceptance number 1, I will use here binom distribution because our lot size was 500 and sample size is 30. So we can use binomial distribution. Now I type here binom. You get here binom dist. So you double click it. Now you get numbers. Here numbers is your acceptance number. So you can select this acceptance number. You can freeze it by pressing F4 key. Then you put comma. Next is trials. Trial denotes your sample size. You can again freeze it by pressing F4 key, you see dollar sign, it indicates that that particular cell has been freezed. Now, probability is the fraction defective, so I will not freeze this probability of acceptance, and then cumulative, because I want to get the probability of having at most one defective when I inspect the sample of size 30. So I will write here true. I will double click it and then I will close the bracket. Okay, and then I will enter it. So here when fraction defective is 1 and sample size is 30, acceptance number 1. So getting one defective in such a sample, probability at most probability is 1. So you can say acceptance probability is 1. So similarly, if I drag this, you get the different probabilities for corresponding values of uh, different fraction defectives. You can click here and you can see anytime that the sample size acceptance number is same, only p value is varying. You have to click on enter key. You can, and you these color combinations gives you where what values you have chosen. Okay, so similarly you can get probabilities corresponding to acceptance number 2. So I write here binom, binom, binom distribution. Here number is your this, freeze it by pressing F4 key, comma, trials is your 30. So again press F4, comma, P is your this thing, comma, cumulative, write true, and by double clicking and closing bracket you get some probability. Okay, similarly you can write for this acceptance number 3. So by now number is your 3, freeze it, sample size, freeze it, probability, and then true. Okay, so then you select both and drag. So you should be careful when you select and drag so that no data, wrong data is chosen and you get the exact value. So here it comes the probability. So this is now the probability of acceptance corresponding to acceptance number 1. This is the probability of acceptance corresponding to acceptance number 2, and this is the probability of acceptance for acceptance number 3. So now we want to plot the OC curve. So we select all these values and go to insert line and select this one. Okay, so you get the curve. 3 curves. Here you can select these horizontal lines and then relate them. Now you go to the select data on this horizontal category, edit, and you select these fraction defectives. So when you select, you get these values here. You can extend, okay. Then the series you can edit it by typing this is for C is equal to 1. Okay, this second series is for C acceptance number equal to 2. Okay, and the series third is for acceptance number equal to 3. Okay, so that's the final. You can have, okay. So finally you get these values. You get this graph. This is OC curve. This blue one is for when acceptance number is 1. This red one is for acceptance number 2, and this green one is for acceptance number equal to 3. Now let's calculate producer's risk and consumer risk. So producer risk is 1 minus probability of acceptance. 1 minus probability of acceptance. So here I write 1 minus binom, because binom distribution is the probability of acceptance, and this number is 1. Then your number trials, I will freeze here trials only. Then I will take this probability, that is basically your fraction defective, and that is AQL level. So I will again freeze it, and then I will write true, and this one. So I get this 1 minus probability of acceptance, that is probability of rejection, and that is equal to your producer's risk. And I drag it horizontally. That's why I have not freezed the acceptance number. So here it will take 2 value. You can note down this is 2. The equal value, sample size, and all those remains same. And here you can see our acceptance number is C, and the remaining values are same. Now I find out the probability of acceptance at LTPD level. So here this is the probability of acceptance. So simply I would write binom distribution. This number is your again 1. Then trials are 30. I will freeze it. Then probability is LTPD value. Fraction defectives at LTPD, I will freeze it again. Then true. Okay, and then I drag it. Okay, now my total experiment is set up. I have calculated the producer risk, consumer risk corresponding to equal LTPD value for different values of C and sample size, this one. Now you observe one important thing. As I told you earlier, the consumer wants acceptance number as low as possible, whereas producer would like to keep the acceptance number as high as possible. You see here, consumer risk is increasing with acceptance number. Consumer risk is increasing with acceptance number. So consumer would like to keep the acceptance number value as low as possible. Whereas the producer risk is decreasing with increase in acceptance number. So the producer would like to keep the acceptance number as high as possible. So now it is difficult to choose the appropriate value of acceptance number. Similarly, if I change the size of this sample size, let's say this 10. Can I have 10 sample size? Let's see. Now you see that producer risk is significantly low when sample size is small, whereas consumer risk is high. So again, for any value of sample size, the producer risk will decrease with acceptance number and consumer risk will increase with acceptance number. But let's now analyze the effect of sample size. So when sample size is low, or say you can say 10, producer risk is significantly here low, but consumer risk is quite high. Now if I increase it to 20, you see producer risk has increased and consumer risk has decreased. But again increase it and put here 30, again it is increasing and it is decreasing. I can put it in 40, it is again increasing and it is further decreasing. So now it is, you can note that as sample size increases, producer risk is increasing, consumer risk is decreasing. So you can say that producer would like to keep sample size as low as possible, whereas consumer would like to keep the sample size as high as possible. You also noted that acceptance consumer prefers smaller acceptance number, whereas your supplier or producer would like to keep acceptance number as high as possible. So they are contradicting. They are contradicting as far as values of both sample size and acceptance number are concerned. So how to decide the optimal value? So this OC curve helps, and as you can see is on this screen, that how this OC curve is helping you to find out what should be the sample size and acceptance number. Now you know that producer risk should not be more than 5%. It should be less than 5%. It should be always less than 5%. Okay, and it should be less than 10%. So keeping these conditions in mind, you see here that this is the situation which satisfies these conditions. So when we have sample size of 30 and acceptance number 3, you have producer risk about 3% and consumer risk about 8%. So here a very good lot, the probability of rejection is only 3.06%, and when a bad quality lot which have 22% defectives, here good quality lot means only 4% defectives are there, and such a lot would have very high probability of acceptance and very low probability of rejection, that is almost 3%, and a bad quality lot having 22% defective would have probability of acceptance only about 8%. So if I choose sample size 30 and acceptance number 3, then this situation satisfies both the producer as well as consumer, and such a single sampling plan would be acceptable to both the producer and consumer. If you put here 40, it will not be acceptable to anyone. Similarly, if you put 20, it will again not be acceptable to anyone. So by hit and trial, you can find the value, and this hit and trial method you can perform easily on this Excel sheet. So this Excel is going to enable you to find the appropriate values of sample size and acceptance number, which will satisfy both the producer and consumer. So this is what we have plotted a theoretical operating characteristics curve for sample size n and acceptance number 1 or 2 or 3. Now let's discuss how we can plot an OC curve, an actual OC curve. So what you can do, you can have 500 similar kind of items. These may be some stones, pebbles, or your pea grains. Out of these, like you may take peas or 500 peas. Out of 500, if you take 5 yellow peas and rest 495 green peas, then such a combination will have fraction. And if you consider these yellow peas as defective items, then 495 green peas would be considered as good item. Then in such a combination, fraction defective, that is defective by lot size, would be 0.01%. Similarly, you can have 25 yellow peas and 475 green peas, and such a lot would consist fraction defective equal to 0.05. So by having different combinations of yellow color peas and green color peas, you can make different lot size, equal lot sizes having different fraction defectives. Now, out of any lot, you what you do, you take a sample of 30 items. You take a sample of 30 items and count the yellow color peas out of it. So those would be considered as defective. Now for any value of, say, we say, because we found that N30 and C equal to 3, acceptance number equal to 3 satisfies both the producer and consumer. For that particular theoretical OC curve, we want to find out an actual OC curve. So you take out of this 500 population and having uh, these five combination. For first combination, what you can do, in you take a sample of 30 items and count the yellow color piece, and those would be considered as defective. And in any sample, if you find yellow color piece more than 3, then that lot, then it will be rejected. And you can write there, you mark uh, here 1, 2, 3. So you are taking for each lot, for each particular combination of lot, you take 10 sample one after another, and each time you find out the number of defectives. And whenever the number of defectives are more than acceptance number 3, you write reject, other you write accept. So, and after that, what you do, total number of rejection are to be divided by, or total accepted numbers are counted and they are divided by 10. So that will give you the probability of acceptance at this fraction defective. And this way you can repeat for all combinations. So for like here, when you have 75 yellow color peas and 425 green peas, such a combination, the fraction defectives are 15%. And for this, we take a sample of 30 items, and if in that sample, if you find defectives or yellow color P is less than 3, then you write accept. Okay, then you mix it again thoroughly. You take a random sample of 30 items, you again count the number, and you decide whether it is to be rejected or accepted. And this procedure you repeat for this combination 10 times. And then you count the number of accepted and rejected. And then you write total accepted by 10 trials. So this will give you the probability of acceptance at this fraction defective. So now those values you can put on this graph which we plotted. So corresponding to those fraction defectives, you can mark here those probability of acceptance values, and that way you can compare this theoretical OC curve with actual OC curve. Thank you for patience hearing. If you like today's session, please share it and like it and give your feedback. Thank you.